So for this question, the quadratic curve of the y equals to -2 bracket x minus 1 3 minus x intersects a horizontal line only at the point P. Okay, so next we need to find the x-intercepts and y-intercepts of the quadratic curve. Now, general finding x-intercepts, that is easy. Remember that the x-intercept is where we usually will substitute y to be equals to 0, since we are talking about intersecting the y-axis. The x-axis, where basically your y will be equals to 0, right? And if you just observe this graph, you can see that the coefficient of x squared is basically +2, right? So it's actually a happy phase. And if we are thinking about the intercepts of the x-axis here, this is where we will know that on this point, the value of the y-coordinates will be equals to 0. All right. So next, I want to find the x-intercepts of the quadratic curve. So what do? Part 1, I sub y equals to 0 to find the x-intercepts. So y is equals to -2, x minus 1, 3 minus x. I substitute y as 0. Okay, so this is just a very humble quadratic equation, -2 x minus 1. So this just gives me x minus 1 equals to 0, or 3 minus x equals to 0, which turns out to be x equals to 3 or x equals to 1. Alright, so these are the x-intercepts. Now if I want to find the y-intercepts here, what do? I will sub x to be 0 lah. Alright, so y-intercept here basically means that, you know, if we're talking about the intersection of the y-axis, this is what we call the y-intercept, right? And along the y-axis, all the x-coordinates are 0. Huh? So to find the y-intercept, we will substitute x to be 0. Alright, remember on the y-axis, all your x-coordinates are 0. Right, that's why I can do that. And this point lies on the curve. Since I know that at this point x equals to 0 and it also lies on the curve, I substitute x equals to 0 into my equation. So y equals to -2, 0 minus 1, 3 minus 0, and that evaluates to be the answer 6. Okay, now part 2. The coordinates of P here. Now here we talk about a quadratic curve intersecting the horizontal line only at point P. Right, so this is my point P. This is my horizontal line. Now for it to intersect at only one point, only at point P, it has to be this line that touches the turning point. It cannot be any other line, because any other line is going to cut the curve at more than 2 points. So if I were to draw any other line, it will either cut at 2 points or cut at 0 point. The only line that can cut at 1 point would be the line that cuts through the turning point. Okay? So, how do we find this point? Is we first need to locate, because we know that it cuts at the turning point. What we need to do is we need to locate the turning point. We need to locate the turning point. Okay? So we need to locate the turning point. So how do you locate a turning point? Remember that in such a case, where we know that the x-intercepts are 1 and 3, right? The turning point is basically the midpoint, right? So the x-coordinate of the turning point can be found by taking the two intercepts divided by 2, which is just 2 lah. Okay, so in this case, it's just 2. So that's the x-coordinate of the turning point. Now I sub this in. If I sub x equals to 2, then y will be -2 of 2 minus 1, 3 minus 2, which gives us -2. So this is the y-coordinate of the turning point. So you notice that I take x equals to 2, right? I will substitute it into the curve. Because this 2, at this point x equals to 2, if it lies on the curve, when I substitute in, I can find the y value. Okay, so that is that's the coordinates of the curve. Okay, So the coordinates of P is none other than 2, -2. Okay, thank you.